Okay, now it's recorded. Okay, recorded. All right, let us do a little bit of revision, yeah, and then we straight away answer some tutorial question. Okay, so okay, so phasor diagram. Okay, we learned already about phasor diagram. Okay, also we learned about pure resistor, pure capacitor, and pure inductor. So here some revision. Okay, so some revision about the phasor diagram, equations, and also the relationship between voltage and current. Right. So pure resistor memang the voltage and current in phase. Yeah, they in phase, they rotate together. They rotate together. Yeah. So this is a sine equation lah. Yeah, current is sine, voltage is sine also. Sine equation. Okay. Power later. Yeah. Power is we use these two formula multiply. Yeah, instantaneous power. We use these two formula multiply, then we get this formula. Okay. So you can see that relationship between V and I, they are in phase lah, in phase. So they travel together. And then pure capacitor is current leading voltage. Yeah, ICE, isn't it? Remember that ICE. So it's current leading voltage. Current lead by 90 degree. Current is in front. So current is sine graph and voltage is negative cos graph. Negative cos. So this is current leads voltage by 90 degree lah. 90 degree or pi over 2 radian. Pure capacitor. If power is we multiply these two formula, yeah, I sine multiply by negative V cos, so we get this formula. Negative 1 over 2 I naught V naught sine 2 omega t. This one later I will discuss. Okay. So pure capacitor is current in front, current leading voltage. Pure inductor is voltage leading current. Yeah, LE. Remember the LE? Voltage leading current. So current is sine graph, voltage is cos graph. Okay, voltage is cos graph, positive cos. And then this one is voltage lead current. Voltage lead current by 90 degree. Okay, now we have the circuit with combination of resistor and capacitor. RC circuit. Just now we only learn pure resistor, pure capacitor, pure inductor. Means they each of these circuit only have one component, either resistor, capacitor, or inductor. Now we have RC circuit. RC circuit means a circuit that has both resistor and capacitor. Both resistor and capacitor. So how do we find the total voltage of resistor and capacitor? Total voltage. We combine the phasor diagram between resistor and capacitor. So look at resistor. Resistor voltage is the voltage is in phase with current. Capacitor is the voltage is below. See that voltage is below. So we combine these two. So we have VR for resistor, VC for capacitor. See that? Just combine the phasor diagram. So Pythagoras theorem between voltage R and voltage C, yeah, VR and VC. This is the total voltage. We do Pythagoras theorem, total voltage. See that? Or we call it voltage source. Voltage source. Okay. So this is current equation is sine. VR equation is sine also, but VC is negative cos. Remember that? VC below is negative cos. So this one is the voltage. You see, current. You see, current leads. Current is in front because it's anti-clockwise rotation. So we can see current is in front of V. This is the V. Current is in front of V. So current leads voltage by phi radian. This is the phi radian, the phase angle between current and voltage. Okay. So this phi radian is no longer 90 degree. No longer that. Last time pure capacitor, the phi is 90 degree. Current lead voltage by 90 degree. but this time is not pure. It's not pure. It's RC circuit. Last time is pure C. Now is RC. That means got resistor and capacitor. So now the current lead voltage by 5 radian. This 5 radian is less than 90. No longer 90 degree. Understand? Because got VR. Because got VR. Okay? But it's still current leading. See that? It's still current leading. Yeah? Because for pure capacitor, it's always current leading. 90 degree. So for RC also current leading, but it's no longer 90 degree, but less than 90 degree. Okay? Because we have VR now. Okay? Now, RL means we just combine the graph for the phasor diagram for resistor and inductor. Combine. Remember, resistor is, how is resistor? Resistor is voltage in phase. Inductor is voltage is above. You see that the VL is above. So combine these two. We have VR and VL combined. So this is the voltage total. The total voltage. Understand? The total voltage. So Pythagoras theorem lah. Yeah. VL and VR, Pythagoras theorem. That means VL square plus VR square, square root. We get this V. Understand? So this one is like before. Pure inductor is voltage leading current. Voltage leading current by 90 degree. But this time is RL, so it's no more 90 degree, but it's still V voltage leading. See that? It's like pure inductor also voltage leading. So RL also voltage leading by 5 radian, but it's no more 90 degree. It's just less than 90 degree, the 5 radian. Okay? So equation for current is sine, equation for voltage R is sine also, VL is positive cos. See that? So that's it. And then now we have the circuit RCL. RCL, that means we combine all component. We combine all component of we have resistor. So in the circuit in the series circuit we have resistor, we have capacitor, we have inductor. We combine all. Yeah, we know that VR is always in phase with current. VC is below, VL is above. See that? VL is always above, VC is always below. See that? So we combine all three. So now we can, this is the total voltage lah. Understand? If we want to find the total voltage, we need to do like vector diagram. You know, this phasor diagram is like vector diagram. Vector, you know, vector. You need to find the X component, you need to find the Y component first. Once you got the total X and total Y, then we do Pythagoras theorem to get the total voltage for all component RCL. Okay. So for you see for RCL we have three condition. We have three condition. Maybe the first one is XL bigger than XC. That means this XL is like resistance. Before we move on, XL is like, you know, resistance. You know, because resistance has resistor R, so capacitor also have their own resistance. Capacitor also have their own resistance. We call it XC. And then inductor also have their own resistance. We call XL lah. So we have, you know, Ohm's law. We have V equal to IR. We have VC is equal, VR is IR, VC is IXC, VL is IXL. Okay. Yeah, this is peak value. If you see got I naught, V naught, all this is peak value. This is root mean square value. Okay. Impedance. Later I will talk about impedance. Yeah. So okay, look at here. Yeah. So RCL have three conditions. Is either XL bigger than XC, or XL equal to XC, or XL less than XC. Understand? So you look at the difference. If XL bigger than XC, so VL bigger than VC, so VL longer than VC, so that means the inductor has bigger resistance, yeah, or bigger reactance compared to capacitor, yeah, compared to capacitor. The inductor has more resistance compared to capacitor. So that's why the VL is longer, VC is shorter. But if they are equal, if XL and XC equal, so this one also equal length. VL and VC also equal length. They can cancel each other. If XL is less than XC, that means XC is bigger. So VC become longer. VC become longer. VL is shorter. VL is shorter. So VC is longer. So that's why got resultant below. Like that. Understand? So that's the three different cases for RCL. So for RCL, if VL is longer than VC, then we find the resultant VL minus VC. So the resultant is above here. Understand? Remember, this one is combine all resistor, capacitor, inductor. So capacitor, resistor is the voltage is in phase. If capacitor is current leading, so VC is below. If inductor is voltage leading current, so voltage above. Remember? Just combine all, combine all the, see that? Resistor is voltage in phase, capacitor is voltage below, inductor is voltage above. So combine all these three, we have this. See that, class? Understand, class? I want to see whether you understand. You understand, class? Understand, Okay, good. I want to continue. So ada seorang baru masuk, Ya, kenapa ya? Baru masuk ni, ya, kenapa? Why you're not prepared? 8:30 only come in, baru bangun. Okay, so combine all three lah, ya, combine all three. So VL tolak VC dapatlah ini, ya, VL tolak VC dapat ini. So and then ini yang pink ini dengan VR Pythagoras theorem, we got the V total. Inilah V total, class. V total for all the RCL component. V total. So V total ni leading lah. V leads I also. V leads I by 5 radian. 5 radian is between voltage and current. 5 ini between voltage and current. Between the voltage total dengan current total. It's still V leads I because VL lebih panjang. Kita tahu kalau VL selalu voltage lead current. Kan? Nampak tak? Kalau pure inductor, it's always the voltage leading. Voltage leading, you see that? Voltage leading. Kalau hanya pure inductor je, memang 90 degree dah. Tapi kalau tak pure macam RL, so dia masih voltage lead current, tapi phi-nya kurang dari 90 degree lah. Kurang dari 90 degree. Tapi kalau macam RCL ini VL lebih panjang dari VC. VL lebih panjang dari VC. So dia masih voltage lead current lah. Masih voltage lead current. Tapi ini masih bukan 90 degree lah. It's only like 5 radian only. Macam RL circuit lah. Voltage lead current tapi 5 radian kurang dari 90 degree. Understand? Dia ada VC tapi VC-nya kurang daripada VL. So dia punya voltage lead current lah. Okay? Tapi kalau kita tengok, kalau VC pula lebih panjang, kalau VC lebih panjang daripada VL, so maka itu akan jadi current lead voltage lah. Tapi bukan 90 degree lah. Ya. Current lead voltage by 5 radian also. Ya. Tapi bukan 90 degree. Sebab dia ada VR dan VL ini. So bagi ini XL kurang dari XC atau VL kurang dari VC, maksudnya XC atau VC lebih besar. Ya, the XC and VC bigger. XC or VC bigger means VC is below lah, longer lah compared to VL. So this is the resultant. VL minus VC. No, this is actually VC minus VL. I'm sorry, ya, ada salah. VC tolak VL ke bawah lah. So ataupun VL tolak VC, dia jadi negatif lah kan, negatif. So negatif ke bawah lah. Begitu ya. Sebab VC lebih besar. Ya, VC is bigger. So this one and VR Pythagoras theorem, we got V total. So kalau VC lebih panjang means current leading lah. currently anti-clockwise. Remember, it's anti-clockwise. Anti-clockwise, so current is in front of voltage. Current in front of voltage by 5 radian. Understand? Current in front of voltage. So 5 radian. So tengok ini current di mana equation, sin VR punya equation, sin VC punya equation negative cos. Kalau VL punya equation positive cos. So same lah. It's the same ya. For RCL lah, dia punya equation semua sama macam ini. Semua sama macam ni. Okay, ini kalau XC and XL and XC equal or VL equal to VC, that means if this VL and VC they are equal, so they cancel totally. Maksudnya sama panjang, VL dan VC sama panjang, itu panggil resonant. Kalau sama panjang means dia resonant. Kalau VL and VC equal means they are called resonant. So V total voltage-nya hanya VR sajalah. VR sendiri saja. VR sendiri saja. Understand? Equation masih sama macam ini. Okay? So kalau dia sama panjang, VL dengan VC sama panjang, so that it becomes that voltage in phase with current lah. Sebab dia cancel totally, VL and VC cancel totally. So the V is VR. V is VR. So dia punya phi radian is 0. Phi-nya is 0. That means voltage in phase with current. Phi is actually angle. Phi is an angle between V and I. Phi is angle between V and I. So kalau dia V dengan I in phase, so phi radian 0 lah. Okay, power factor ini saya akan ajar nanti. Power factor is actually cos phi ni lah. Cos phi. Cos phi maksudnya kalau phi ialah kosong, cos 0. Cos 0 ialah 1 lah kan? Cos 0 ialah 1. So kalau resonant memang power factornya 1. Z dia pun minimum. Impedance. Z is apa? Z is total resistance lah. Kira total resistance dia. Dia kira lah minimum. Z is minimum, which is equal to R only. And current is maximum lah. Because when total resistance is minimum, current is maximum. Nanti saya akan explain ni. Jangan risau. So, these are all characteristic of resonant lah. Understand? Okay. So, okay. Ini nanti saya akan explain tengok Z apa? Z ialah sebab kita dalam circuit itu kita macam RCL kan. RCL we have XC, we have resistance, we have XC, we have resistance, we have XL. So kalau combine tiga-tiga ini ialah total impedance. Total impedance is like what? Total impedance is like total resistance. Total resistance. Tapi kita guna Pythagoras theorem untuk cari impedance. Okay? Nanti saya explain ni. Okay? So, okay, let's look at so for RCL circuit in series, there's only one current IRMS passing through a component, but there are different value of VR, VC, and VL. Okay, voltage different, but current is the same for all. Okay, and I will explain about this later. So let us look at some question. Okay. Class, are you okay, class? Are you okay? Okay, Yeah. Let's continue. Let's continue with some questions. Okay, Okay, let's look at the tutorial questions. Okay, question 1 actually I discussed with one class already. So if the class I haven't discussed about question 1, hold on, later I will discuss with your class. I start with question 2. Okay, I start with question 2. So I'm going to snapshot this thing. Okay, we discuss question 2 now. Let's discuss using the OneNote. Okay, let's look at that's good. Chapter 6, right? Correct. Okay, let's look at this question, class. So, first of all, how to do this? First, identify what circuit. The most important thing is identify what circuit. Is it pure what? Pure capacitor, pure resistor, pure inductor, or is it RC, or is it RL, or is it RCL? Identify what circuit, sir. Identify what. The first step is always identify what circuit. Identify what circuit first, then only you start. Like this one, look at this question. This one is say about you have resistor and in series with capacitor. So only resistor and capacitor lah. So what circuit is this? This RC circuit. RC circuit. What is RC circuit? So let's look in series. Maksudnya macam mana? Ya, ikut graph ni macam mana? Begini kelas. So we have this total voltage, we have resistor, we have capacitor, like that. Okay. So this is the voltage source or total voltage. Just now we find, remember just now we find about the total voltage. This is the resistor, so we have VR over here, and this is the VC. Okay, so we have RC circuit. This one we put as XL lah, because you know, capacitor also have own resistor. We call it XC. Yeah, not C, but XC. Okay, so voltage source, and then in this circuit also we have this AC current, not AC current, not DC. Yeah. So current is the same for both component. Current for resistor and current for capacitor is the same, but voltage different. Voltage we have VR and VC. They are different. Okay. So remember what you learned just now. This one. You see that this where is it? RC circuit. This one lah, class. RC circuit. So just now the V source, the V total from the source is this lah. The V here. This V is V source lah. Understand? This V is V source, and then we have VR. VR is this one. VR is this one, and VC is the below one. This is VC. Remember? And then the current is in phase with the VR. And then this one is V source. Remember, you find this one is V source. V source. VR and VC different. VR and VC different, but current is the same for both. That's why we only have one current vector here. We only have one current. Okay, class, to find V source, we no need to consider current. No need to consider current. This V source only consider VR and VC only. That means only VR square plus VC square root. Pythagoras theorem between VR and VC only to get V source. The current is not involved. Current is just like to mark where is the sine graph only. Okay, that's it. Okay, so that's it. V source is this the long one, the long Pythagoras theorem hypotenuse. This one is V source. Okay. Now, okay, I give you, so you can find, give you this value. This is R, and this is C. Later you have to find XC, Later you have to find XC. Ada formulanya, nanti saya ajar. Okay, you need to find XC later. So voltage, this voltage across resistor is this one. Okay, so how to do? Voltage R is in volt and T in second. So write an equation for the current. Write equation for the current. Oh, this one, that means you need to okay, this one got changes in the, I can see got changes in the phasor diagram. Okay, got changes in the phasor diagram. So now your VR is cos. Your VR is cos. That means how? He say your VR is cos. So that means cos graph is, remember class, if the graph is here is sine graph. If the graph above is cos graph. If the graph below is negative cos. Remember this class? Do you remember about the phasor diagram? I taught you already. Phasor diagram. Do you remember this? Over here is sine, above is cos, below is negative cos. Do you remember? Do you remember this one, class? Remember, here is sine, here is cos, here is negative cos. Okay, so let's look at this one. Yeah, so good. If the good that you remember this one. Yeah. Okay. Let me put it here. Okay, but tapi dia kata VR nya cos. So ini ada sikit kelainan daripada nota. Nota kamu punya VR adalah sine. Nota you punya VR adalah sine graph. Tapi ini soalan ini VR-nya cos. So di mana? So current equation pun lain juga. Ya. So kita lukis dulu phasor diagram. Kita berdasarkan apa yang kita sudah belajar di sini. Okay, semua ada dekat sini kan? Mana lagi ada yang 11 13 orang tak ada lagi ya? 13 orang. Bukan lah. 17 orang tak ada di sini ya. Tak tahu you di mana kelas ya. Tidur kah? Okay, so based on what we have learned about phasor diagram, this is sine, this is cos, negative cos. So let's adjust to this phasor diagram ya. Okay, so look at here. Sorry, redraw again. Okay. So now your VR dekat atas, your VR di sini. Your VR di sini. Remember this is anti-clockwise rotation So kalau anti-clockwise, yang leading mesti di depan phasor ni ya, leading. Okay, this is RC circuit, right? Remember what you know about RC circuit? RC circuit. Kalau resistor macam mana? Voltage R macam mana? Voltage R in phase with current kan? Kalau capacitor is apa? Ice. Remember ice? Ice. So siapa leading? Current leading. Remember that? Current leading voltage. So this one is what? Current leading. So this one current leads voltage C. Macam tu. Okay, current leads voltage C. Current di depan. So tengok balik ini. So you rasa current di mana? Kalau voltage resistor in phase with current. So kalau VR di cos, VR di atas, VR cos. Ya, VR cos. So you rasa current di mana? Current mesti in phase dengan VR. Current mesti in phase dengan VR. Remember that? Because in phase. So current equation also cos. Now VC pula. VC di mana? Kalau pure capacitor dia apa? Kalau pure capacitor macam mana? Pure capacitor current lead by 90 degree, isn't it? 90 degree. So mesti 90 degree between current and VC. Okay. So look at here. Current sudah saya tahu current di sini. Dan for capacitor is current leading. Current leading VC. So VC di mana? VC mesti di sini. Nah, VC mesti di sini. Because remember, it must be rotation anti-clockwise. So, kalau yang leading punya mesti di depan dia. Macam like capacitor, right? Is current lead voltage VC. So dia actually, this graph is almost the same like this one. You see that? It's almost the same like this one. Dia macam inilah kelas, macam ini. Ya. So dia boleh juga current di atas. Boleh juga current di atas kalau pure capacitor kan. Boleh juga current di atas. Kalau current di sini, VC di sinilah. Dia masih current leading voltage by 90 degree. See that? So dia ini dua benda ini dia boleh rotate punya, ya. So current is, if current di sini, voltage di bawah. Kalau current di atas, voltage di sini. These two is the same. current still lead voltage by 90 degree. This one also current lead voltage by 90 degree. See that, class? It's just like the whole graph rotate only, rotate ke atas, rotate ke atas. Boleh faham, class? Boleh faham? Can understand? Can understand, class? Understand, huh? Good. Okay, let's continue. So current still lead VC by 90 degree. Tetapi sekarang kita let's say nak cari dia punya voltage total kan. Voltage total bukan 90 degree lah, bukan 90 degree dengan current. Sebab dia ada VR di situ. Dia ada VR. So this is the V source. Understand, class? This is the V source. So inilah 5 radian between current and V source. So is the current leads V source by 5 radian, which is less than 90 lah. This one less than 90. Tapi current leads VC by phi equal to 90 lah, phi 90 degree. Kalau VC saja memang 90 degree lah. Kalau VC saja memang 90 degree, tapi kalau V source kurang dari 90 ya, kurang dari 90. Not 90 degree, 90 degree lah. Phi. This is degree, this radian. But you can change lah, you can change either degree or radian lah, understand? Okay, currently VC by 90, but if V source is less than 90 lah. Okay, because got VR. Okay, good. Okay, don't waste any more time. Let's continue. So question A just now, what's the equation for current? What's the equation for current? Yeah, equation for current. So you see, VR is cos, so current also cos lah. Current also a cos graph. I equal to I naught cos omega t. Understand? And then question B, what is the capacitive reactance? Capacitive reactance means XC. Nak cari XC. So XC formula ni apa, kelas? XC is 1 over omega C. Later you will learn another one, inductor XL. XL is omega L. Omega L. So also you can change it to, omega is 2 pi f, omega L, XL is 2 pi FL. That means you can use frequency, yeah, here. This is a formula to find XC and XL. They are almost like resistant. Just that this XC and XL, they are resistant specific for capacitor. This is resistant specific for inductor or solenoid. Understand? Okay, now capacitive reactance, how to find? So it's 1 over 2 pi FC. So let's calculate 1 over 2 pi. What's the frequency? Actually here this formula is actually formula 1.2 cos omega t. Remember? So this one is already omega. So actually you no need to find the frequency 2 pi f. You just use this formula also can, yeah, because this is already omega. Be careful with the unit also. VR is in volt. This one is in second. Sometimes it can be millisecond. Understand? Can be millisecond. So be careful with the unit. If this time is in millisecond, so the omega also not in SI unit anymore. Yeah, it's in per millisecond. So be careful with all the units. Yeah, be careful with all the units. Now is second. Okay lah, second is okay. Okay, so now let's continue from 1 over omega c. So is let's continue. So second. This one. Okay, 1 over omega. Omega is 2500. C is what? Yeah, I give you C here. 5 microfarad. Micro exponent. Micro is negative 6. Micro negative 6. So what's the answer, class? Give me the answer. Yeah, what's the answer? Come on, give me the answer. What's the answer? Where is my calculator? So never mind. I think I just refer to the answer here. Yeah, I just refer to the answer here. Where is the answer? Get the bottom line answer. So this is a question 2, right? Question 2. What is the answer? I think I take the whole picture here because I need it. Yeah, I need this. Okay, I just put it somewhere here. Yeah, for me to refer. Okay, so what's the answer just now? Question 2B is 80 ohm. Yeah, 80 ohm. Yeah, 80 ohm. Yeah, so 2B just now is 80 ohm. Okay, so you calculate, you got 80 ohm. Oops. Is that correct, class? Do you get the same answer? Do you do calculation on your own? I hope so, yeah? I hope so. I hope for the good. So write an equation for voltage across capacitor. Voltage across capacitor equation. How to determine? Determine from phasor diagram. That's why I say phasor diagram is most important. Phasor diagram, most important. Most important. From phasor diagram, you can get all the, you can get all the equations. You can get all the graphs. Yeah, sine graph, cos graph, negative cos graph. So phasor diagram always start with phasor diagram first. Start with phasor diagram, then from there you can get equations and graph. So like you see, he want the equation for capacitor. So equation for capacitor is a sine graph. It's a sine graph. I can straight away put it VC equal to V naught C sine graph sine omega t. See that, class? So easy. Okay, but I need to find, I have for omega already. Omega is 2500, but I don't have V naught C. So how to find V naught C, class? Okay, it gives you this one. This is actually V naught L, class. V naught R. This here, this V naught R. V naught R. V naught R is 1.2. Okay, V naught R is 1.2. Okay, V naught R is 1.2 volt. Yeah, V naught R. This is a peak voltage lah. Peak voltage. Peak. Look at here. Look at here. Where's my notes? Look at here. What is V naught R, class? V naught R. V naught R is I naught R. V naught R is I naught R. So I can find my I naught. V naught R is I naught R. And then V naught L is I naught XL. I use these two. V naught R is I naught R. V naught L is I naught XL. Okay? I can find I naught. Once I got my I naught, I can find my V naught L for the equation of, VC, yeah? Right, V naught C. Once I have my I naught, I can find V naught C for equation for capacitor. I need the value of I naught. XC just now I got 80 ohm, right? 80 ohm. Okay. So V naught R is I naught R. Okay, let's do it. V naught R is what? I naught R. So 1.2 just now. R is what? R is 300 ohm. 300 ohm. So let's do it. 300 ohm. So what is I naught, class? Let's do it. I don't have my... Wait. Let me find my calculator. So, where is my calculator? Okay. Yeah, over here, my calculator. So now let's find my calculator. Okay, let's press the button. Do you press or you just wait for me, class? Do you press on your own or you just wait for me? Yeah, don't be like that. I hope for the good. For the better. I hope you are not passively doing Not passively listen only, yeah. You are actively writing down the notes, yeah, and doing the question also. I'm talking to human, not the wall, huh? I'm talking to human, not the wall. Yeah, all of you are alive, yeah, class. Class, okay, so this is the current I naught. So this is 0.04. Okay, so I got the I naught already. I got my I naught, so I can find my V naught C already. V naught C is I naught XC. I got my XC just now, so I just put it the I naught over here. XC is 80. So let's calculate. Multiply by 80. So it's 0.32. 0.32 volt. Next time, class, by 8 o'clock, already stand by, yeah, with your phone, just waiting. No need for me to tell you, yeah. Just stand by already. Then Google Meet saja link masuk, terus masuk. Tak payah tunggu lagi, tak payah tunggu arahan. Ya. Sebab kamu sudah tahu jam 8 mesti ada kuliah. Tak payah saya bagi tahu kemarin, hari ni kena bangun awal untuk kuliah. Tak payah, itu sudah tahu memang ada kuliah. Okay, so baik. So let's go. So this is the equation for VC is 0.32 sine omega is what? 2500T. Itulah dia, kelas. Itulah dia. Yeah. So then you must write where, mesti tulis ini, where VC in volt, T in second. Itulah dia, kelas. Voltage in volt and time in second. Okay, that's it. You got the answer. Yeah. Yeah. Itulah dia. Mesti tulis ini ya. Unit mesti ada. Unit mesti ada. Okay. So let's look at the next questions. So what's the next questions? Oh, okay. So let's go back to the tutorial questions. Chapter 6. Okay, how about this one? Okay, how about this one? So, and let's all right. Okay, so let's talk about this one. Okay. So let's talk about this one, class. An alternating voltage with frequency. Okay, sini ada bagi frequency. Sini ada bagi frequency. Resistor, this is R. And this is capacitor. This is C. So this is identify what circuit is this? Resistor and capacitor again. So again, this RC circuit, just like just now, yeah, like just now. So question A, how to find the reactance XC? XC is 1 over omega C ataupun 1 over 2 pi FC. Kali ini guna frekuensi, ya. So 2 pi frekuensi ni apa? 150. C dia lah 2 microfarad. Micro is negative 6. Negative 6. Okay, microfarad. Okay, what's the answer, class? Let's calculate. Let's calculate. Times 150 times 2 exponent. What is exponent? Negative 6. Okay, so the answer is 1 divided by answer. So it's yeah, XC is 530.52. Yeah, 530 ohm. The unit is ohm, class. Ohm. Yeah. This is ohm. The unit is ohm. Like resistor lah. Resistor. Question B. What's the impedance? Impedance is what? Remember? Draw the phasor diagram dulu. Macam mana nak cari? Buat phasor diagram. Lepas tu lukis. Lukis current dulu. Lukis current. Okay. Lepas tu X. Ini RC circuit. Ini VL. VL di mana? VR. VR di mana? In phase kan? Betul tak? VR. And then VR in phase. Then capacitor is ice kan? Ice. Ice. So that means current leading kan? Betul tak? Current leading. So and rotation anti-clockwise. So that means current leading. So VC di bawah lah. VC di bawah. VC di bawah kelas. Okay? Sebab current di depan VC 90 degree. Okay? And then this one all we will get V source. Over here is V source. So this angle over here is 5 radian. So you can see current lead voltage by 5 radian. Okay, so this is V source, Pythagoras between VR and VC, V source. Okay, class, but in this question, it asks you to find total impedance. Total impedance, that means apa? Total impedance. Ini graph macam apa? Tadi macam tadi itulah. Macam tadi itu. See that this one? Macam ini. Ya, dia macam ini. So let me just copy this. Ya, copy this over here. Dia macam ini. Okay. Ya. So RC circuit also. So dia ada VR and VC. Okay, apa itu impedance class? Impedance is kan you ada resistance, you ada resistance for resistor, you have resistance for capacitor. Total. Apakah total resistance dia? Macam voltage pun ada total kan? We have VR, we have VC. So apakah total voltage? Total voltage ni ialah V source lah kan? Total voltage ni adalah V source. Tapi nak cari V source, kita bukan tambah terus, bukan VR tambah VC. Dia bukan VR tambah VC. Salah. For AC circuit, this kalau AC you tak boleh tambah terus. You mesti guna Pythagoras theorem. Ya, untuk cari V source atau V total, you kena apa? You kena Pythagoras theorem. Maksudnya you have to do the VR square plus VC square. Baru boleh. Ini baru boleh. Kalau tambah terus tak boleh. Sama juga. Kalau untuk cari dia punya total resistance, total resistance is like impedance. We call it impedance Z. Ya, total impedance ini spelling dia. Impedance Z. Juga Z itu tak boleh juga R tambah X tambah apa? Tambah XC. Masih ingat tak kamu dulu series circuit? Memang you tambah kan? Namanya tambah terus kan? R tambah XC tambah terus dapat Z kan? Tapi untuk AC circuit, you tak boleh tambah terus. Salah. Salah. Untuk dapat Z, dia macam V source juga. Kena buat Pythagoras theorem. Dia kena buat macam mana? Dia kena buat Z equal to R square plus XC square. Kena buat ini kelas. Kena buat ini. So ini phasor diagram. Actually, we can translate it to. Kamu boleh lukis kepada apa? Boleh lukis kepada ini boleh lukis kepada R. You boleh lukisnya kepada R juga. VR itu macam R. VC ini macam XC. VC is like XC. V source, this V source is like Z. This V source is like Z. Kan? Sebab kita tahu VR ialah IR kan? Betul tak? VC ialah IXC. V source ialah IZ. Understand? VR is IR. VC is IXC. V source is IZ. Because total voltage is like total impedance. Macam tu lah. So kita boleh tukar V ni kepada R, VC kepada XC, V source kepada Z. So untuk cari apa? Untuk cari Z, kita bukan tambah terus. Untuk cari Z, kita tak boleh tambah terus. R tambah XC terus. Kita mesti buat Pythagoras theorem. Sebab Z ini memang Pythagoras theorem between R and XC. See that? Kalau V source, sama juga. Kena VR square plus VC square, punca kuasa, baru dapat V source. Okay? Okay, so find the impedance. Okay, class, find the total impedance. So impedance ialah Z equal to kena R square plus XC square, so equal to R kamu berapa tadi? What's your R? Your R is 300 ohm. 300 ohm. And then XC is what? What is your XC? XC is 530.52 square. Okay, so what's the answer, class? So what's the answer? 530.52 square plus 300 square. So and then square root answer. So the answer is 609.47 ohm. Okay, 47 ohm. Okay, the last one is phasor diagram. Determine the phase angle. Find the phase angle. Very simple. Phase angle how? You actually can see question. You can just use the this one is cos phi. I can use cos phi. Cos phi equal to cos is adjacent over hypotenuse, isn't it? So it's R over Z lah. R over Z. Okay, phase angle R over Z, cos phi, adjacent over hypotenuse, So you got your R is 300 ohm. Your Z is what? Your Z is 609.47. Yeah. So and then you anti-cos lah. Your anti-cos. So what's the answer? Yeah. So anti-cos. So 300 over 609.47. So anti-cos. So anti-cos, the answer. So I got the angle, the phi radian is 60.51 degree. So the angle over here is 60.51 degree. Okay. 60.51 degree. In fact, actually, cos phi, cos phi actually is called the power factor. It's called the power factor, which we will learn later. Power factor. Okay lah. I think that's all for now. Okay, I think that's all for now. Understand, class? You understand? So let's see the answer. Is it correct? Is the answer correct? Question 3, 609 negative 60 point. Yeah, correct lah. So negative 609 and then so but I will write it. You write below the positive x axis lah. You write this below positive x axis. Okay, 609 is correct. And then 531 609 60.5. 531 60.9. Correct lah. Yeah, 60.5. Yeah, correct. Okay, so that's all. Yeah, but you must write below positive axis lah. Below positive axis. Okay, thank you, class. You understand, class? You understand? Okay, that's all for today lah. Yeah, to be continued. Okay, bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Right.
Thank you, sir.
Thank you, sir.
Okay, thank you.
Thank you, sir.